We're going to continue our discussion of graphs of quadratic functions, but for this video we will actually be graphing our quadratic functions and identifying all of the required pieces. So we will graph quadratic functions given in both vertex form and non-vertex form, and for each function we will determine whether the graph of the parabola opens upward or downward. Remember, it will open upward if a is greater than 0 and downward if a is less than 0. We will identify the vertex, and remember, vertex is found by identifying h, k if it's in vertex form, but using the formula to find the vertex if it is in non-vertex form. We will identify the x-intercepts by letting y be 0 and the y-intercept by letting x be 0. We will sketch the function and we'll make sure that we label the axes and show scale. We will determine the axis of symmetry. And remember, that's the vertical line that runs through the vertex, and so it will always have the equation x equals, and it's the x coordinate of our vertex. We will determine the minimum or maximum value, and that will depend on the y value of our vertex. And then we will write the domain and range in interval notation. Our first example is in vertex form. And notice that A is 2. A is positive, therefore this parabola will open upward. Next, we're going to identify the vertex, and because this is in vertex form, we can see that h is positive 4. Remember, vertex form is x minus h, so h is 4. And then k is negative 2. So our vertex is 4, negative 2. Our x-intercepts are found by letting y, or in this case f of x, equal 0. So we're going to set this equal to 0. So we have 0 equals 2 times x minus 4 quantity squared minus 2. And this is such a nice opportunity for us to actually review a process, which is the square root property. And so notice I do not have to expand x minus 4 quantity squared. What I can do instead is add my 2. And then I'm going to just toggle this so that we have 2 times x minus 4 squared. And by adding 2, that gives us a positive 2. And then notice I can divide each side by 2, giving us x minus 4 quantity squared equals 1. And now we can use the square root property by taking the square root of the left side and the positive and negative square root of the right side, giving us x equals 4 plus or minus, and remember the square root of 1 is 1, and then we separate. So x equals 4 plus 1, which gives us 5, or x equals 4 minus 1, which gives us 3. But remember, this came from letting y equal 0. So this gives us our two x-intercepts of 5, 0 and 3, 0. Next, we need to find the y-intercept by letting x be 0. So f of 0 is equal to 2 times 0 minus 4 quantity squared minus 2, which gives us 2 times, well, 0 minus 4 is negative 4, and negative 4 squared is 16. And 2 times 16 is 32, and 32 minus 2 is 30. So this gives us our y-intercept, because we let x be 0, and we have an output of 30. So now we have 4 points. We're going to start sketching this. We're going to label x, label y, show scale in all 4 directions. And I'm going to start with our vertex, which is 4, -2. And then our 2 x-intercepts are 3, 0, and 5, 0. Now notice that the y-intercept is quite high. And even though I'm not going to plot that point, it helps me understand that this is very steep. And then we turn, and then notice my arrows are necessary. It helps me understand that this goes up forever. I'll redo that. This goes up forever. The axis of symmetry is this vertical line for which my function shows symmetry, sameness, left to right. And the equation of our axis of symmetry always depends on the vertex. So the axis of symmetry is that vertical line, and it is x equals, and it's always the x coordinate of our vertex, so x equals 4. And then this parabola opens upward, therefore the vertex is the minimum point. And so the minimum value is our y value of our vertex, so y equals -2. And then finally, for domain and range. Domain is always asking the question, what am I allowed to put into my function? Well, you can put anything into this function, and you can see this as it's going to the left forever and to the right forever. And so the domain is all real numbers. But the range is never going to be all real numbers, because we're always going to have either a minimum or a maximum value for our parabola. In this case, we have a minimum value. So the lowest this goes is -2, and then the arrows indicate this goes up forever, so infinity. You have 3 questions. First question, you're going to identify the vertex for f of x equals 3 times the quantity x plus 2 squared minus 9. Second question, you're going to identify the axis of symmetry for f of x equals the negative of x minus 4 quantity squared plus 1. And third question, you're going to identify the y-intercept for f of x equals 3 times x minus 1 quantity squared. We're now going to graph the quadratic function f of x equals the negative of x squared minus 4x minus 3, and notice that this is in non-vertex form. So the first thing you should recognize is the leading coefficient of our squared term is negative. So because a is -1, this means that this is going to open downwards. For part B, we need to identify the vertex. And because this is in non-vertex form, we need to remember our formula. So x is equal to -b over 2a. And b is -4. And as we said, a is -1. So be careful of all of these negatives. This is the negative of negative 4 over 2 times negative 1, which gives us 4 divided by negative 2, which is negative 2. And now we need to find the coordinating y value, so we plug this into our function. F of negative 2 is equal to the negative of negative 2 squared minus 4 times negative 2 minus 3. Lots of negatives here. Negative 2 squared is positive 4, but the negative of that is negative 4. And then we have plus 8 and minus 3, which gives us 4 minus 3, or 1. So our vertex is negative 2, positive 1. Our x-intercepts are found by letting y equal 0, so we're going to set our function equal to 0. And notice we have negative x squared minus 4x minus 3. So we can, because this is now an equation set equal to 0, we can multiply through by negative 1, which gives us 0 equals x squared minus 4x, or pardon me, plus 4x plus 3. And this actually factors, because the factors of 3 that add to be 4 are positive 3 and positive 1. And setting those both equal to 0, we have x equals negative 3, which gives us our first x-intercept of negative 3, 0. And our second one is x equals negative 1. So our second x-intercept is negative 1, 0. Finding our y-intercept, we want to let x be 0, so f of 0 is equal to the negative of 0 squared minus 4 times 0 minus 3. 0 squared is 0. The negative of 0 is still 0. 4 times 0 is 0. And so please notice, the only thing that is left is c, our constant. And so our y-intercept is 0, comma, negative 3. It is our constant, 0c, and that will always be true. So let's plot what we have so far. So we're going to label x, label y, show scale in all 4 directions. So we have our vertex, negative 2, 1. We have our 2 x-intercepts, negative 3, 0, negative 1, 0. And we also have this fourth point, our y-intercept, 0, negative 3. And we can get a fifth point by symmetry. Notice our x-intercepts are symmetric over our line of symmetry, which we'll graph in a minute. But I can get another point of symmetry, which is 4, negative 3. So I have 5 nice points here. Notice our axis of symmetry is x equals negative 2, and that's how we were able to actually get that fifth point. Our maximum value is y equals positive 1. Our domain, as always, will be negative infinity to positive infinity. And then careful here, because this parabola opens down, our range is negative infinity and then it goes to our maximum value, which is the y-coordinate of our vertex, +1. Your first question for this set, identify the vertex for f of x equals 4 times x squared minus 8x minus 1. Identify the x-intercepts for f of x equals the negative of x squared plus 6x minus 5. And lastly, identify the y-intercept for f of x equals 3 times x squared plus 5x.